All right, so I think this is recording. Let's take a look at these three equations. These are rational equations. I can see that I have ratios and I have fractions within these equations, and I have variables in the denominator. So whenever I have variables in a denominator in a rational equation, I need to be concerned about extraneous solutions. I have to avoid division by zero. All right, so let's take a look at number 7. Whoa, in number 7, sometimes I rotate this and I don't know exactly how I did it. All right, it's letting me get this back. Okay, sorry about that. Now, uh, if I look here at number 7, first I'm going to factor these denominators. So this 1 over 2x plus 2, I'm going to write it as 2 times x plus 1. The second term, x squared minus 1, is a difference of perfect squares. I'm going to factor that to x plus 1 times x minus 1. And over here, I don't need to factor, I can't factor this denominator. So now that this is in factor form, I can see what denominator I'd like. I want to have 2 times x plus 1 times x minus 1 as a common denominator to these three terms. So this first term is missing a factor in the denominator. I'm going to multiply this by the number 1. The only I'm going to write 1 is x minus 1 divided by x minus 1. In the second term, it's missing a factor of 2 in the denominator. So I'm going to take this second term and multiply it by the number 1, but I'm going to write 1 as 2 divided by 2. On the right-hand side, I have 1 over x minus 1. It's missing a factor of x plus 1. So I'll multiply it by the number 1, but write it as x plus 1 over x plus 1. But it's also missing a factor of 2. So I'll write it as 2 over 2. Well, now I have the same denominator in all three terms. The order of the multiplication is not the same. But I know that multiplication satisfies the commutative property that if you have a times b, it's the same thing as b times a. They refer to that as the commutative property for multiplication. Addition has the same, but subtraction and division are not commutative. We'll see that in a later problem in this video. So let's come back to here. If I were to multiply every term by this common denominator, all these denominators would cancel, and I would have over here in this first term, I would have x minus 1. Here I'd have 5 times 2, which is 10. And on the right-hand side, multiplied by 1, well, you get the same thing back, and x plus 1 times 2 is 2x plus 2. So this equation is much easier now to solve than the original ugly equation with these fractions. I need to make the comment here above, though, that when I look at this denominator, that when I do get a solution, that I cannot accept the solution of negative 1, because negative 1 plus a positive 1 would give me a 0 in the denominator, and I can't divide by 0. That would be undefined. I can see from this other factor that 1 minus 1, that if x were allowed to equal 1, again, we'd have division by 0, and we have to avoid that. So when I come down here and solve this equation, as long as I don't get one of these two answers, I'm going to be fine. So on the left-hand side, I have x plus 9. On the right-hand side, 2x plus 2. Take away 2 from each side, take away x, and I'm getting a solution of x equals 7. And if I haven't made a mistake, I'm going to be fine, because that is not going to cause division by 0. So this is the only solution to this equation. So let's go ahead and shrink this up and try to tackle number 8. All right. if we take a look at number 8, before I jump in and start talking about number 8, I want to talk a little bit about properties of addition and subtraction. And we just mentioned it in that last equation, the commutative property. We know that A plus B is the same thing as B plus A. And that property is called commutative. So we know that addition has a commutative property. Now, for two real numbers A and B, A minus B is not going to equal B minus A. They're going to be equal in magnitude, but they're going to be opposite of each other in sign. You know, if you have 5 minus 3, that's a positive 2. But if you have 3 minus 5, that's a negative 2. Okay? So in algebra, there's often the case, like we have up here, that we're going to want to change the order of the subtraction of 3 minus x and rewrite this as x minus 3. But you can't just do that without some, really, I guess you can think of this as factoring out a negative 1. Or like I say, that subtraction, if you change the sign, if you change the order of subtraction, these are now not equal to each other. They're opposites of each other. But if I multiply that by a negative 1, now they are the same. So if I change the order of subtraction of A minus B to B minus A, if I want to keep the value the same, I need to multiply one of these sides by negative 1. So let's plug it in with numbers. Maybe you can see that better. Let's go back to our 5 minus 2. 5 minus 2 is 3. Well, 2 minus 5 is a negative 3, but if I multiply that by a negative 1, then on the left-hand side I have 3, and on the right-hand side I have 3, that these two expressions are equal to each other. And another comment that I want to make is if I have a fraction, let's say I have the fraction negative 1. I can write negative 1 divided by positive 1, or I can write positive 1 divided by negative 1. When I have a fraction, that negative sign, I can choose whether to put it in the numerator or to put it in the denominator. So let's see if making those comments will help you understand my solution here a little bit better, because I can see what exactly it is that I want to do in this problem. On the left, I have two terms on the left-hand side, a single term on the right-hand side. I want to figure out a common denominator, but before I do that, I need to factor things. So on the left-hand side, I have 2 over x plus 3. And then right here, I'm going to just leave this for 3 minus x for just a second. And over here, x squared minus 9 factors to x plus 3 times x minus 3. All right, so that's the denominator I want to have here. And over here I have the x plus 3. It's missing the x, but 3 minus x is not equal to one of these two factors. I'm going to have to change that. So I've got 2 over x plus 3. And remember that if I change the order of this subtraction, if I make this x minus 3, these denominators are no longer equal to each other. But they are opposites of each other. You know, so if I make this, if I multiply that by a negative 1, think about distributing that negative 1 through. That makes that x the negative, and the negative 1 times the negative 3 makes that positive. So now I'm going to be able to make my comparison and see exactly what I want for a common denominator. Now remember that I also said when I have a negative sign, I can choose whether to put that in the numerator or in the denominator. So I'm going to rewrite this middle term again, the second term again, only instead of addition, here, I'll keep this addition. That 5, I'm going to move that negative sign up with that 5, and now x minus 3. And now I think it will be easier for all of the students to get a common denominator. So I've got 2 over x plus 3. That's missing a factor of x minus 3. this negative 5 over x minus 3 is missing, that denominator is missing a factor of x plus 3. And on the right-hand side, I have the denominator that I want. So I don't have to do anything to it. Let's shrink this up a little bit, give ourselves some room. All right. So also at this point, let's make the notation that when I do have my final solution, that I don't want that solution to be negative 3, because negative 3 would cause division by 0. I don't want a solution of positive 3. That would also cause division by 0. So now, since I have the same denominator in all these terms, if I were to multiply all these terms by that common denominator, all I'd have left is the numerator. All right. So in this first term, 2 times this x minus 3 gives us 2x minus 6. And this negative 5, if we multiply both terms in the binomial by negative 5, we get minus 5x minus 15. And that's equal to 6. All right, so 2x's take away 5x's, hey, that's negative 3x. Negative 6 minus 15, that's minus 21. If I add 21 to each side, I'll get negative 3x is equal to 27. If I divide both sides by negative 3, I'm getting x equals negative 9. And negative 9 is not going to give me division by 0. It's not negative 3 or positive 3. So, hey, that's my solution here. So you're going to have to spend a little bit of time. It is not a common problem, but it's not uncommon either. Occasionally, you're going to see situations where you want to change the order of that subtraction. And when you change the order of that subtraction, you need to remember to put a negative 1, a negative sign outside of that binomial, or try whatever the expression is. Let's shrink this up and take a look at number 9, our last problem here. Yeah, move that out of the way. All right. So if we look at that now, I don't have to do it in this case, but it's just a common habit. I like to write things in standard form. I like to have these leading coefficients be a positive value. On the left-hand side, I'm going to leave this fraction alone and have this 3 over 2x minus 3. But on the right-hand side, I'm going to change the order of this subtraction and make it 2x minus 5. And I'm going to make that numerator a negative sign. So I can do that. You can go back and look at that previous steps and stuff and justify me doing that. We're going to see multiple ways to solve this as a rational equation. This is also called a proportion. So even though I have variables in the denominator, the technique that students really like is to cross multiply. When you have a fraction equal to a fraction, you can cross multiply. Oftentimes, students mistake reducing a fraction to lowest terms as cross multiplying. This is called cross multiplying because you're crossing over that equal sign. You're going to multiply along this red diagonal, and then you're going to multiply along this blue diagonal and set those two products equal to each other. So let's do that. If I multiply along that red diagonal, I get 3 times 2x minus 5. And if I multiply along this blue diagonal, I have negative 1 times 2x minus 3. So I guess really I didn't have to change the order of that subtraction with cross multiplying, but again, I'd kind of like you to see that. You don't have to do, as long as you get the correct solution, your solution doesn't have to look exactly like mine. I do want to make some notation here, though, that this 2x minus 3, that I can't let x be 3 halves because that would cause division by 0. Here at 2x minus 5, I can't let x be 5 halves because that would cause division by 0. Now, how did I get those? I just took the 2x minus 3, set it equal to 0, and solved. I took the 2x minus 5, set it equals 0, and solved, and then said I don't want 2x minus 3 to equal 0. Therefore, I don't want x to be 3 halves. I do not want 2x minus 5 to equal 0. Therefore, I do not want x to be 5 halves. I don't think we get either one of these answers, but let's look and see. We always have to be aware of it. Let's multiply both of these terms by 3. So I've got 6x minus 15. Let's change it. I guess I'm changing the order of subtraction again to 3 minus 2x. Let's add 2x to each side. Let's add 15 to each side. Let's divide by 8. And since these are both even numbers, this fraction reduces to half of 18 is 9, half of 8 is 4, to 9 over 4. And that's not one of the values that I'm concerned about. So, hey, that's my final answer. Ask me any questions. Don't be afraid to ask questions about when I change the order of the subtraction that I put a negative sign out in front. That's a common thing that you see in solving equations. I didn't just make this up. I will hope that helps, and I will talk to you later.